Today we're going to be combining like terms. So it's important for you to understand what a term is so that you know how we can combine them and what like terms are. So terms are going to be either numbers, real numbers, variables, or the product of a real number and variable. Okay, and I'll explain that with a picture in just a minute. The important thing to know is that terms are going to be separated by either addition or subtraction signs. So let's look at what I'm talking about here. Okay, these are all examples of terms. So when I said a term could be a real number, that's this term right here. Okay, technically, it's this term right here. Oop, nope, I liked it better the first way. Okay, this term is a 4, and I'll explain why I changed that. So that's a real number. A variable is going to be this term right here, just a letter all by itself. And then lastly, when we have the product of real numbers and variables, that's when we're going to have a situation like this, where we have a number, a coefficient, being multiplied by a variable. Now, terms are going to be separated by addition and subtraction signs. That's why when I said this was the real number, I changed my mind, because the sign there, the subtraction sign, is actually what's separating our terms. So our terms are going to be the things that are in between the addition and subtraction signs. Now, today's lesson is on combining like terms. So in order to understand what a like term is, we need to talk a little bit about some examples. So like terms are going to be the exact same variable with the exact same exponent. Okay? They have the exact same variable with the exact same exponent. So if we look at these like terms here, we can see they both have z's. It doesn't have anything to do with the coefficients in front. We're just looking at the variables with the exponents. So z and z, those are going to be like terms. When we look at this next problem, I have 5ab and 10ab. Since both terms have an a and a b, those are like terms. And then finally, if we look at this example, I have 7x squared and 9x squared. So same variable x with the same exponent squared, those are going to be considered like terms. Now, unlike terms are going to be different. They're not going to be same variable, same exponent. So here's an example. This has an a, this has a b. Since a and b are not the same, not alike. In this example, we have 5a and we have 10ab. In order to be like terms, they both have to be exactly the same. An a and an ab are not the same. And on our last scenario here, we have an x and an x squared. So same variable, but they don't have the same exponent. We can only combine things together when they are like terms, when they have the same variable with the same exponent. So let's think about what we did the other day when we were writing expressions. So in this problem, I have some watermelons and I have some strawberries, and I'm going to write an expression. So when I look at this right here, I see 3 watermelons, and I have 3 strawberries, and I have 2 watermelons right here, and finally, I have 1 more strawberry on the end. So this expression, 3 watermelons and 3 strawberries, and 2 watermelons and 1 strawberry, we can simplify and combine our like terms. And what I mean by that is I can put all of my watermelons together. If I think about that, and I had 3 watermelons and 2 watermelons, that's going to give me a total of 5 watermelons. And I can put all of my strawberries together. So I have, oops, let's change that color. I have, we'll try one more time changing the color, and if it doesn't work, there we go. 3 strawberries and 1 more strawberry. So 3 strawberries and 1 more strawberry are going to give me a total of 4 strawberries. So that's an example of combining like terms with a picture. What we want to do is be able to combine like terms without a picture. And the easiest way I've found to do this is using grouping. When you use grouping, you want to think about the numbers and the variables, like each term, is going to be attached to the addition or subtraction sign that goes with it. So the way I do these problems is I look for things that are the same. So I see right here, I have a 5x, and I see right here, I have another 3x, okay, and I know they both have same variable, same exponent, 5 and 3. In order to combine them, I just put them together. And because I have 5x plus 3x, like I said, that plus 3 goes together, 5 plus 3 is going to give me 8x. Okay, now like terms, those were my x terms. I also have these two numbers. These two numbers are going to be alike. Okay, I have a -2 because that subtraction sign goes with that 2, plus 7. So -2 plus 7 is going to give me 5. And since it's a positive 5, I'm going to put a plus 5 there. In this next problem, we've got a lot going on there, so we have to look for our like terms. So like terms are going to be things with the same variable, same exponent. To make it easy on me, I usually start on the left-hand side. So I see this has an h squared. So I'm going to look across my problem until I see other h squareds, and I'm going to circle them. So when I look at this, I see I have -2 plus 9. And I'm only writing the numbers down because I know when I combine these together, it's still going to have the term h squared. So -2 plus 9 is going to give me 7. Next, I'm going to look and I see I have 4h here. My colors, hang on. There we go. I have 4h, that's not an h, right here. So 4 plus 7 is going to give me 11. And since it's a positive 11, I'm going to put a plus inside. So remember, the variable stays with it, and I'm adding it because it's a positive 11. And then last but not least, I have this -3 here, but that -3 doesn't have anything to combine with it, right? Because it's the only number I have that's by itself. So that's just going to kind of tag along here at the end because there's nothing to combine with it. Okay, let's try 2 more. If it were me, go ahead, oops, the 2 that are down there on your worksheet, those you can do on your own. All right, flip over to the back of your worksheet here. It says the distributive property is going to be used to simplify expressions. So in addition to combining like terms, we can also use something called the distributive property. The distributive property shows groups. If you think back to our expressions, remember yesterday we looked at this and this was 3 groups, and inside each groups was a 2x plus 9. So if we think about this in words, what we can say is I have 3 groups of 2x plus 9. In expanded form, if I was going to show you what this would look like, what it means is I have 3 groups of 2x plus 9. Here's 1 group. Here's 2 groups. And here's 3 groups. So this is kind of a complicated way to write out this problem. What I would have to do here is now combine like terms. So all of my x's, 2 and 2 and 2, 2 plus 2 plus 2 is going to give me 6 x's. And then I'm going to do the same thing for my numbers. I have 9 plus 9 plus 9 is going to give me 27. So there's a much easier way to do these kinds of problems, and it's called using the distributive property. When you have the distributive property where we're talking about these groups, we can multiply each term that's inside our parentheses by the number of groups that we have outside of our parentheses. So remember, this means I have 3 groups of 2x. 3 groups of 2x is just like saying 3 times 2x, which is going to give me 6x. Next, I have 3 groups of 9 right here. 1, 2, 3 groups of 9. 3 groups of 9 is the same as saying 3 times 9, which is going to be 27. And if you look, hopefully you'll see that this answer we got by using distributive property is the same as this answer that we got from using expanded form. This is just an easier way to do the problem. Okay, so the last thing we want to talk about is using the distributive property and combining like terms all together. So the first problem is just distributive property, just one more practice here. So I'm going to take this 2 that's outside my parentheses. I'm going to multiply it by both things inside my parentheses, and that's 6. Don't let it fool you, it's a negative 6 there. So I'm going to do 2 times 3, which is going to give me 6x. And then I'm also going to do 2 times negative 6. 2 times negative 6 gives me negative 12. Okay, this is what we want you to be able to come up with as your answer. The expanded way, this means 2 groups of 3x plus 6. So remember, that would be 3x minus 6. Sorry, I misspoke there. And 3x minus 6. So you can see if we combined it, 3x and 3x is going to give us our 6x. And then our negative 6 gives us our negative 12. Okay, but we don't want you to have to do that. We want you to be able to use the shortcut, which is our distributive property. So this time, when I do this problem, we're going to have to distribute and combine. So I'm going to take this negative 8 and multiply it by both of these things inside. So negative 8 times 2 is going to give me negative 16. Don't forget the x. Negative 8 times negative 1 gives me positive 8. But we're not done because we still have this 5 here. Now, we don't multiply because that 5's not inside our parentheses. So that 5 just kind of tags along. But when you look at this problem, hopefully you see that we've got some like terms here. We've got 2 numbers that can be combined. So there's nothing that combines with this negative 16x. But I have 8 plus 5, and 8 plus 5 is 13. So we simplify negative 16x plus 13. And it's important for you to know that when we simplify problems, when we simplify them, an expression is considered to be in simplest form if there are no like terms and no parentheses. If you see parentheses, you have to use your distributive property. If you see like terms, you have to combine them. Otherwise, you don't have your simplest form.